Dear viewers of Acti.com, by Vetri from Pondicherry. Good evening. Today I am going to discuss another important chapter in inorganic chemistry, that is general principles and process of isolation of elements. Normally, the wealth of a country depends upon the minerals that are available in a country. India is gifted by nature with full of natural resources, minerals and ores. Let me discuss today how ores can be obtained from the minerals and it can be purified with several steps. Let me point out the difference between minerals and ores I can discuss. First, let me take minerals. What are minerals? Minerals are the natural materials occurring in air where the metals or non-metals that we are interested or their compounds are present. Let me repeat again. Minerals are the natural materials occurring in the air where the metals or non-metals or their compounds are present. Specific example, rock salt, limestone or minerals. Then you can raise a question. What is the ore? Ore is defined as a mineral. Ore is defined as a mineral which may be a single element or compound or complex mixture of various compounds from which a metal can be readily and profitably extracted. This is the correct definition for ores. So, ore is defined as a mineral which may be a single element or compound or complex mixture of various compounds from which a metal can be readily and profitably extracted. This is the most important. Readily and profitably extracted. So, from this definition itself, you can know the difference between minerals and ores. So, better it is noteworthy, kindly follow, that ores are minerals, but all minerals are not ores. This is the most important sentence, you have to keep it in mind, students. It is noteworthy that all ores are minerals, but all minerals are not ores, because we are getting anything that we will call it as minerals, but only from the minerals, whatever we are getting readily and profitably, we are getting metals or non-metals, then only we will call it as ore. So that is the main definition of ore. Okay, let me discuss. I have already pointed out the wealth of a country depends upon the minerals. So let me take specifically a few examples. In India, what are the minerals available and specifically the state? So better before starting this chapter, let me give an idea. The mineral, aluminium mineral, it is available in Kerala. I am giving only the state, I am not going for the specific area. The next, antimony, the mineral, most important, again available in Punjab and Karnataka mainly. Another mineral, asbestos, which is available in Karnataka and Rajasthan. Barytes, another important minerals, it is available in Tamil Nadu and Andhra Pradesh. Bauxite, another most important mineral, which is available in Jharkhand and Maharashtra. Beryllium, the most valuable metal, which is available in Rajasthan and Tamil Nadu. Continues list. Carborundum, another most important mineral, which is available in Assam and Tamil Nadu. Cement is the most valuable, we know, the material. It is available in Madhya Pradesh and Rajasthan mainly. China clay, another most important mineral, which is available in Jharkhand and Kerala specifically. Chromite, another minerals, which is available in Jharkhand and Tamil Nadu. Coal, the most valuable minerals, resources of any country. Coal, here in India, it is available in West Bengal and Jharkhand, and even some part of Tamil Nadu, Neyveli. Now, cobalt, which is available in Rajasthan and Kerala. Another important important mineral, copper, which is available in Rajasthan and Chhattisgarh. Diamond, the most valuable element, which is available in Madhya Pradesh and Chhattisgarh in India. Gold, which is available in Karnataka. Graphite, another mineral, which is available in Rajasthan and Andhra Pradesh. Gypsum, again, the most important mineral, again available in Rajasthan and Tamil Nadu. Iron, the most important metal we are commonly using in all purposes, available in Jharkhand and Chhattisgarh. Continues. Lead, the most important again, available in Jaipur and Tamil Nadu. Manganese, another most valuable mineral, available in Madhya Pradesh and Chhattisgarh. Mica, another important mineral, which is available in Jharkhand and Bihar. Monazite, another most valuable minerals, available in Kerala and Bihar. Petroleum, the most valuable, which is available in Assam. And pitch plant, the another most important mineral, available in Bihar and Rajasthan. This continues. Salt, commonly you say, common salt, Rajasthan and seashore of Southeast part. Saltpeter is again available in Punjab and UP, Uttar Pradesh. Tungsten, the most highest, the metal having highest melting point, tungsten, which is available in Bihar and Maharashtra. Uranium, which is available in Bihar. And finally, zinc, the most valuable mineral, which is available in Rajasthan. These are the important minerals that are available in India. I have pointed out a few. Let me go for the minerals that are available in the largest producer of the world. Let me point out some few minerals. The largest producer, the country which produces the maximum quantity. So gold, number one mineral, which is available in South Africa and China. South Africa, Kimberley is famous. Famous for diamond. So gold, it is available in South Africa and China. Copper, which is largest producer, is Chile, United States. Aluminium, the metal, which is the mineral, most important mineral, it is largest producer is China and Russia. Iron, the largest producer, again China, Austria. Manganese, the mineral largest producer in the world is China and South Africa. And zinc, the largest producer is China and Austria. Coal, the largest producer as usual, China and United States. And finally, uranium, the most wanted material, that is available in Kazakhstan and in Canada. It is the largest producer of the world. So these are the important minerals, the countries they are producing the largest producer. I have listed a few. Okay. With this, let me go for the interior. So, I have already clearly pointed out what is the difference between minerals and ores. So let me concentrate on ores, sources of ore. So ores we are getting from three sources. One is from earth we are getting, from sea we are getting, and from living organism also we are getting ores. This is the most important sources from which we are getting the ores. Now, so here I have given a list. The most abundant element that is normally present in the earth, sea, a living organism. So I have given the list because sometime competitively question can be asked. So I am giving the list. So among that is the source that we are getting from earth. The most abundant element is number one is oxygen. The next element is silicon dioxide. And the element can kindly follow the metal, which is the most abundant metal in the earth is aluminium. Kindly follow. It is not iron, it is aluminium. Next only takes, that is iron takes the priority. And finally calcium. So I have given some of few. So number one oxygen, number two silicon. And metal largest, most abundant metal in the earth is aluminium, next comes iron, next comes calcium. This is regarding for Earth. Coming for the C source, as usual, oxygen is the most abundant element. Next element, that is hydrogen, explain. The next one, chlorine, sodium and magnesium. So most abundant metal in the sea is sodium because the form of sodium chloride, highly compound. And same way, coming for a living organism, from the living organism, whether plants or animals, so most abundant element is hydrogen. Kindly follow, it is not oxygen, hydrogen. Then coming for the next is oxygen, that is oxygen number 2, carbon number 3, nitrogen number 3, that is 4, and sodium, that is the most abundant element present in the living organism, metal is sodium. So just for comparison, I want to give information. The most abundant element, the metal is aluminium in Earth, sodium in sea, and again sodium in living organism. So comparatively, question you can expect from this. Okay. With this idea, let me go for wars. Classification of wars. How we can classify the wars? So I can broadly classify into two ways. One is native wars or free wars, type 1, and combined war, type 2. So entire war, if you take, I can classify into two types. Type 1 is native wars or free wars, and number 2 combined wars. Let me discuss in detail. What is the native wars? Very simple. Wars which occur in free state are called native wars. Free state, without combination of other elements. Specific example, gold, platinum, silver, copper. So these are chemically inert elements, inert metals. So these metals will be occurring as free state. So that normally these wars will call it as native wars. And these are called normally nucleus. This is the most important information regarding the native wars. Next one, combined war. This is the most important. What is combined wars? Let me define now. Combined wars are those which exist as a compound or mixture containing a minimum of 2 or more elements. This is the most important. Let me define again. Combined wars are those which exist as a compound or mixture containing a minimum of 2 or more elements. Minimum of 2 or more elements. So based on this, I can classify further combined wars into a number of types. What are they? Number 1, oxide wars. Number 2, sulfide wars. Number 3, carbonate wars. Number 4, halide wars. Number 5, sulfate wars. Number 6, silicate wars. And number 7, phosphate wars. These are the common occurring in nature, in the combined wars. So let me go specific example. In each case, I will explain with the specific example, then I will go for the process. So coming for the oxide wars, I have given the list now. So bauxite, there is an oxide war having the molecular formula Al2O3.2H2O, molecular formula. The main metal that is we are getting from this is aluminium. So aluminium is the metal we are extracting in profitably from the ore is bauxite. Molecular formula Al2O3.2H2O. Number 2, cuprite is another oxide ore. Molecular formula is Cl2O. The main metal is copper. Element is copper. So copper we are extracting mainly from this cuprite. The third one, hematite, another oxide ore, molecular formula Fe2O3, ferric oxide, and iron is the main metal that we are extracting from this ore. Zincite, another oxide ore, molecular formula zinc, ZnO, zinc oxide. The metal is Zn. The next is tin stone, 5. Tin stone, there is an oxide ore, molecular formula SnO2. Then the tin correspondingly Sn, we are getting extracting from this oxide ore. The next one is pyrolusite. Pyrolusite is another oxide ore having the molecular formula MnO2, manganese dioxide. And from this ore we are getting manganese metal we are extracting profitably. Pitch blende, another oxide ore, having the molecular formula U3O8, and we are getting uranium metal from this oxide ore. This is the interesting information regarding this oxide ore. Let me go for the next one, type 2. Second one, sulfide ores. Under the sulfide ores, number 1, copper pyrites, having the molecular formula is a mixture of two compounds, Cu2S and Fu2S3. And mainly from this we are extracting copper. So copper pyrites we are extracting mainly copper. So it's a sulfide ore. The number 2, copper glands, molecular formula Cu2S and metal is copper again. So we are extracting again copper from copper glands. The third is zinc blende. It's again another sulfide ore having the molecular formula zinc sulfide. Is that ENS? Again, we are extracting profitably zinc from this particular sulfide ore. The next one, cinnabar, another most important sulfide ore, molecular formula HGS, mercury sulfide, and mercury is the element we are getting from this. It's a metallic element, it's a liquid metallic element. And galena, another most important sulfide ore, molecular formula PBS, lead sulfide, and we are getting profitably lead from this particular sulfide ore. And argentite or another name silver glands, molecular formula Ag2S, silver sulfide, and we are getting silver from this particular sulfide ore. This is the most important information regarding the sulfide ores. Now, let me go for the next one. Third one, carbonate ores. The most first one is magnesite. Magnesite is the carbonate ore. Molecular formula MgCO3. The magnesium is the metal we are extracting profitably from this particular carbonate ore. Second one, dolomite. Dolomite is another most important carbonate ore, having the molecular formula is a mixture calcium carbonate and magnesium carbonate, CaCO3 and MgCO3. It is present, but mainly magnesium we are extracting from this again. So dolomite is the carbonate ore from which we are extracting profitably magnesium. The next one, calamine, another most important carbonate ore, molecular formula zinc carbonate, ZnCO3, zinc carbonate, and we are getting the metal zinc. We are getting this. The next one, mulsite, another most important carbonate ore, is a mixture again, a mixture of two compounds, copper carbonate and copper hydroxide, molecular formula CuCO3 dot CuOH twice, and mainly copper we are getting extracting from this carbonate, mulsite. Limestone, another most commonly available carbonate ore, the molecular formula CaCO3 or calcium carbonate we will call it as, the mainly calcium we are extracting profitably from these carbonate ores. Next one, type 4, halide ores. The fourth type. Among the halide ores, the first one, rock salt, the most common, sodium chloride, common salt we will call it as, mainly sodium we are extracting profitably from this. Kernelite, another most important halide ore, is a mixture having potassium chloride, magnesium chloride dot 6H2O, molecular formula KCl, MgCl2 dot 6H2O, and mainly magnesium we are extracting from this kernelite halide ore. Horn silver, another most important halide ore, molecular formula AgCl, we'll call it as silver chloride, and silver we are extracting from this halide ore. And silvine, another most important halide ore, molecular formula KCl, we'll call it commonly potassium chloride, and potassium is the metal we are extracting mainly from this halide ore. Cryolite, another most important halide ore, is a mixture having, that is 3NaF.AlF3, or another way, Na3AlF6 we call it as, mainly from this we are getting aluminum metal we are extracting from profitably from this halide ore, cryolite. Okay, let me go for the next one, fifth type, sulfate ores. Among the sulfate ores, Epsom is the most common, most important salt, having the molecular formula MgSO4.7H2O, and magnesium is the metal we are extracting from this mainly. That is magnesium sulfate, that is heptahydrate. Gypsum, another most important sulfate ore, having the molecular formula CaSO4.2H2O, calcium sulfate dihydrate. Mainly calcium is the metal we are extracting. Third one, barytes, another most important sulfate war. Molecular formula BaSO4, and mainly barium is the metal we are extracting from this sulfate. Then angelcite, another most important sulfate war. Molecular formula PbSO4, I can call it as lead sulfate. Mainly lead is the metal that correspondingly we are getting from this, the angelcite. Next one, type 6, silicate ores. Under the silicate ores, I have here listed 3. One is asbestos, mainly the molecular formula CaSO3.3MgSiO3. Mainly magnesium we are extracting from this asbestos silicate ore. And feldspar, another most important silicate ore, is again a mixer. So K2O.Al2O3.6SiO2, or another way KAlSi3O8. So mainly aluminum is the source, metal source we are getting from this feldspar. We are extracting aluminum profitably from this silicate ore feldspar. Finally, under the silicate ore, mica, the molecular formula K2O.3Al2O3. This is the most important. So mainly here .6SiO2.2H2O, mainly aluminum we are getting from this. The most important. So we are extracting aluminum from mica. So this is the most important silicate ores I have discussed. Now let me go for the next one. Finally, phosphate. Under this, phosphorite is the most common, only one. So it's called molecular formula Ca3PO4 twice. Mainly we are getting phosphorus from this non-metal. We are getting from this phosphate. So these are the commonly available ores from which we are extracting profitably the corresponding metals or non-metals that I have discussed. The next, I am entering into the most important part, that is, what is the general procedure we have to follow to extract the element in pure form. So, general principles and the process of isolation of elements. So, there are mainly 5 steps are involved. Kindly follow, student, this is the most important part. So far what I have discussed only just an introduction. So really what we are entering, this is the entering part. So it consists of 5 steps. What are the step 1? So step 1, natural ores we are getting from naturally can be converted into powder ores by step 1, that is by grinding. Grinding is a step 1. So when we are getting ore from naturally as minerals, and then after taking this mineral, we have to convert it into powder form. So conversion of natural ores into powder ore is the step 1. That we will call it as grinding, step 1. Number 2, second step, the powder ores can be converted into concentrated ores. So here I can use the step is called concentration, step 2. So what is the meaning of this? So when powder ores, when we are concentrating into a concentrated ore, means unwanted impurities can be removed. So we'll get water, gases, unwanted impurities can be removed from the even sand, something like that. Material can be removed. So the required quantity of metal or non-metal will increase the percentage. That's called powder ore to concentrated ores. That's called step 2, concentration. And step 3, the concentrated ores can be converted into a suitable form of ore, whatever form we need, so that they can get profitably, we will extract the metal. So it's called suitable form. So this is called conversion. Step 3, it is called conversion. Step 3. So concentrated ores can be converted into suitable form of ore by step called conversion. Third step. Okay, the next one. So from suitable form of ore, now we can extract the impure metal. So we can extract impure metal. So that step 4 is extraction. Extraction of impure metal from suitable form of ore. Step 4. And finally, step 5. Impure metal can be converted into pure form of metal. That's called step 5 is the purification. This is the most important steps. So let me summarize. So step 1, grinding. So natural ore can be converted into powder ore. Step 2, concentration. Powder ore can be converted into concentrated ore. Step 3, conversion. So concentrated ore can be converted into suitable form of ore. either oxide ore or sulfur ore, so that we can easily extract metal. And step 4, that is extraction. Step 4, suitable form of ore can be converted into impure metal, metal in the impure form. And final step, purification. Impure metal can be purified to pure metals, pure elements. So we can get the final pure form. So this is the 5 steps involved. So I am going to discuss each step with the detail. Kindly follow me. First, let me go for step 1. That is conversion of natural ores into powdered ores. Step 1. We know, I have already pointed out, normally we are getting minerals, naturally occurring minerals. It may be from the rock, even from the earth, from anything. So these natural ores that are obtained from air or sea or living organism contain large quantities of foreign matter as impurity. And these impurities are called gangue or matrix. This is the most important information. So along with the metals or non-metals, we are interested. So there may be impurities. That impurities we are calling it as gangue or matrix. So here means we have to remove this gangue or matrix. So the natural ores along with gangue or matrix are irregular in size, and so they should be grinded first to get powder form. So natural source along with gangue or matrix are irregular in size. So in order to purify, first what we have to do, the first step, we should grind this entire ores into powder form. That is step 1. Okay. Now step 2. That is, conversion of powder ores into concentrated ores. That is step 2. So conversion of powdered ores into concentrated ores, that's, I can call it as step 2. Okay. The next operation of removal of gangue or matrix from the ore is technically known as concentration or dressing of ore. Kindly follow, this is the most important. So technically we will call it as removal of gangue or matrix, we will call it as concentration or dressing of ores. Okay, and the purified ore is known as concentrate. That is called concentrate. This is step 2. So there are a number of methods available. So important methods of concentration of ore are as follows. So this is the most important step here. So kindly follow me. What are the important steps that are involved in step 2? So concentration or dressing of ore under this step 2, we have a number of methods. First method, hand picking. Second method, gravity separation. Third method, froth flotation process. Fourth method, magnetic separation. Fifth method, electrostatic concentration. And finally, chemical separation. So after converting into powder forms, the powder form of metals or non-metals, we can concentrate, we can increase the concentration by removing impurities. What way? These are the method. Hand picking, gravity separation, froth flotation process, magnetic separation, electrostatic concentration and chemical separation. So depending upon the nature of impurity, nature of element, nature of ore, we have to adopt these methods to get concentration. Okay, let me discuss one by one. First, hand picking. Hand picking, very simple one, no further explanation required. Let me read simply. Generally, the ore is separating from the main stock in a sufficient degree of purity by simply picking it by hand. More workers are normally employed for this purpose, and they will remove separately after making the powder form. Right. And then eliminating the adhering rocky material by breaking with a hammer. This is a normal common method available. Hand picking. Okay. Number 2. Gravity separation. This is another most important method. We can concentrate or we can dressing of ores. This method actually is based on the differences in the specific gravity. Kindly follow. Question can be asked. Gravity separation is based on the differences in specific gravity of metallic ore and the earthy impurities. This is the most important. Based on the specific gravity of the metallic ore or the impurity, we can adopt suitable methods of gravity separation. So commonly used method here are 1. will-flay table method, and there is hydraulic classifier method. These two methods are commonly used under the gravity separation to concentrate the ore. So let me discuss one by one. First one, will-flay table method. So what we are seeing is the diagram for will-flay table. This is our table. So kindly follow here. Here in this part, we are introducing the powdered ore, and from this side we are going to send water perpendicular to the adding of ore, and this instrument is vibrating in this direction, that is vibrating in this direction. So it's consisting of ripples there. So what will happen now? That is, so when this table, will-flay table is vibrating, and when we are adding from the top the ores, and we are sending water, we are sending it perpendicular to the input of the ore, the lighter materials, impurities will come up, but due to jerking of this table, and will be washed away water. So that washing will be collected separately. The heavy materials, metals, will become slowly and will be collected separately. This is the specific will-flay table method. You see that. Now, so this I have already pointed out. This method is particularly suitable for dense ore like that is SnO2. So heavier materials can be separated by will-flay method because it will move slowly. I have already pointed out here a stream of water is made to flow across the table at right angle to the slope. At right angle to the slope, you have to make to flow water, so it can easily wash away the lighter impurities. And each jerk, when we are operating the table, with each jerk, the lighter gangue particles are thrown upward and washed away water, and are carried away the table by stream of water. And whereas the heavier ore, which cannot be washed away water, they are moved slowly towards the bottom of the table. We can collect separately. This is the basic principle involved in the will-flay table method. This is the most important information. So the idea here it is, will-flay table method is applicable for the ore having particularly dense ore. That's number one. That is the most important. So here the basic principle is by flowing water perpendicular to the addition, right angle to the addition of the ore, we are doing during jerking. Only the impurities washed away, heavier particles are coming slowly, and we can collect separately. This is the will-flay method. The next, what you are seeing is the hydraulic classifier method. Can you follow? There is a hopper at the top, powder ore. At the hopper, we are adding the powder ore, and from bottom, we are introducing a water. We are supplying from the bottom. So when the ore is coming down along with the impurities, lighter impurities, and heavier ore, it is coming down. So what will happen now? Because of the cone shape, the rate of flow of water can be controlled here at the bottom. So only lighter impurities will go upward and will be washed away, whereas heavier one will be collected here at the bottom. This is the most basic principle of this hydraulic classifier method. So lighter material will be washed away water and be collected gangue at the top through the side tube, and whereas at the bottom the concentrated ore will be collected. This is the basic principle is hydraulic classifier method. Just see, let me hear. So this method suitable for ores containing lighter gangue. Kindly follow. So if the impurities are lighter, we can apply this one. Normally this is suitable for the most important lighter the gangue materials. So hydraulic classifier is a conical reservoir fitted with a hopper at the top. You have seen already, I already showed it. Hopper at the top and a pipe at the bottom through which we are sending water. So finally powdered ore is dropped into the conical reservoir, and a powerful stream of water is passed from the bottom of the reservoir. So when water is coming down from the bottom, when we are adding from the top the ores containing the gangue, lighter gangue, so gangue will be carried away, washed away by the water, but the heavier metal coming down and collected. And from the top, we are collecting separately the gangue, lighter gangue. This is the basic principle involved in hydraulic classifier method. Okay. The third method, that is called the froth flotation process. This is another most important method. Froth flotation process. What you can see here, this is suitable for sulfide ores. Now we can just see here, actually, the ore containing sulfide ore. So we are adding, kindly follow, I will come back the diagram, you can just see here. So this method is suitable for sulfide ores. That's the first information I want to give. The diagram I will come back later. So after getting this information, if you look into the diagram, you will have a very clear idea. This method is suitable for sulfide ore. Okay. This method is based on the different wetting characteristics of the gangue and the ore with water and oil. Can you follow? The former being preferentially wetted by water, that is gangue by water, and the latter by oil, and the ore with oil. This is the most important information. So this is suitable only for sulfide ore. Froth flotation process is suitable for sulfide ore. And normally the method is based on the different wetting characteristics. So gangue is normally wetted with water and the ore is normally wetted with oil. So what are the chemicals used in this method? Frothers, number 1. Number 2, collectors. Number 3, activators. And number 4, depressants. Frothers commonly oils will use. Collectors normally phenol, xanthates. Xanthates will be used, collectors. And activated generally will use copper sulfate, copper salt, inorganic ion. And depressant normally will use sodium cyanide. Okay, now you will come back to the diagram, you can easily understand this. So what we are having? So when we are having the sulfide ore and we are mixing here, so with this, through this compressed air will be sent inside. So what will happen now? Okay, along with water. So water again wetted with the gangue is wetted with water and the sulfide was wetted with oil. So oil was just overfloating over that. So here at the top you can see the sulfide ores at the top. You can see here. At the top sulfide ores are there, particles. And below that water containing that oil, it is there, the little oil. And gangue, unwanted impurities at the bottom, that is gangue. So this is the way. So what will happen now? Easily by this froth flotation, what will happen now? The normally specifically lead sulfides can be easily having a floating and can be carried away, and we can, after collecting this separately, we can extract mainly concentrated lead sulfide. We can take from this, we can extract lead. The another interesting information here it is, suppose if in this ore, if you are having again lead sulfide along with zinc sulfide and ferrous sulfide also, now by adding, but if the suitable, what will happen now? The polar group of the xanthates will adhere the ore and will be automatically, they will float over along with the oil, it will be floating. So only the lead sulfide will be getting floating, whereas the other ones, zinc sulfide and iron sulfide, will not getting a floating property. So in order to, again after removing the lead sulfide, again if you want to remove again further zinc sulfide, better we'll use again the what you can call the activator we can use. I want to activator, normally I told you there's nothing but sodium cyanide, that is sorry. Activators commonly will use the copper ion. So automatically this will activate. So automatically zinc sulfide will coming out again as a floater. So floating the property can be controlled by these activators. Then again after that we'll get again ferrous sulfide. So even a mixture of different sulfides we can control by controlled floating method by applying suitable activators and activators. We can get this by froth flotation process. We can separate the sulfide. So mainly this is suitable for sulfide. Okay, the next one. Another most important method is magnetic separation. Can you follow? Can you just look at the diagram? I will come back again. So what is the most important is, this is based on the magnetic property of either ore or the gangue we can separate. It is based on purely on the magnetic property of the ore, that is mainly ore can be magnetic property or even the impurity can be magnetic properties. In any case we can separate with the help of magnetic separation. So kindly follow, that is the two wheel over the belt is moving there and it is controlled by the electromagnet. So now let me give some idea, I will come back to the diagram. This method is suitable for the ore having differences in magnetic properties of the ore and the gangue. Just now I informed. So this method is suitable for the ore having differences in magnetic properties of the ore and the gangue. Suppose there is different category. Suppose we have ore and gangue. Ore is a magnetic and gangue is a non-magnetic, we can separate. Or the reverse also. Ore is a non-magnetic and gangue is a magnetic, again we can separate. And even if it's a mixture of gangue and ore, again different magnetic properties also, we can separate. So this method is suitable for the ore having differences in magnetic properties of the ore and the gangue. So here the pulverized ore is made to fall on a rubber belt. Between two pulleys, wheels, rubber belt is moving. So over the rubber belt we are adding the pulverized ore horizontally on a magnetic pulley. Right. The rubber belt is moving over the magnet. It is under the control of magnetic movement. Okay, magnetic property. Okay. When the belt becomes vertical, it's moving horizontally, no problem. When the belt becomes vertical, non-magnetic gangue fall off. It will be thrown away. Non-magnetic gangue will be fall off, and the magnetic ores are attracted by the magnet and will be immediately fall. So by keeping different vessels in different places, one is fall, other away, another is just nearby the belt, we can collect separately. The gangue we can collect separately and the ore we can collect separately and retained on the belt until they pass out of the influence of magnetic. This is the most important information. Can you follow? So in this is the belt. We are keeping the corresponding gangue and ore. This is under the control of magnetic. Let us assume ore magnetic and gangue non-magnetic. Non-magnetic. Let us assume now. So what will happen now? When it is moving now up to this stage, when it is horizontal, no problem. When it is now going vertical, so non-magnetic material will be thrown away. You can collect separately. Non-magnetic materials will be thrown away from the belt. You can collect separately. And magnetic property just will come on because which is under the control of magnetic property. So it will not be thrown away. It will immediately fall off. You can collect separately. So you can collect non-magnetic material again and magnetic material again you can collect separately. This is the interesting information. So this is the method you can separate using magnetic separation. Okay, the next method is, specific example under this, under the magnetic separation, I have already pointed out. So tin stone, a non-magnetic ore. SnO2, tin stone, a non-magnetic ore can be separated from magnetic impurities, iron, manganese and tungsten. This is the first separation important. So non-magnetic ore can be separated from magnetic impurities like iron, manganese and tungsten. Can be using this method, you can separate. First point. Now number two, the same way, bromide containing iron, a magnetic ore can be separated by non-magnetic gangue, can be again separated. So I have already pointed out. The first case, ore is a magnetic, that is non-magnetic, and the impurities are magnetic. The second case, ore is a magnetic and the gangue is non-magnetic. So the specific example I have given. So by this we can separate suitably using the magnetic separation we can separate. Okay, the next one. Another method I can give here, it is electrostatic concentration. Electrostatic concentration is another method based on the electric field. Instead of magnetic field, electric field. This method is suitable for the ores which differ in the electrical conductivity. Instead of magnetic, electrical conductivity. Okay. The ore particles which are good conductors of electricity become electrically charged as soon as they are brought into an electrostatic field. Despite magnetic field, if you are bringing under the electrostatic field, they will be charged and are repelled by the electrode carrying the like charges. So this is the way we can separate the ore from the gangue. A specific example under this, lead sulfide and zinc sulfide can be separated by this method. Under using electrostatic concentration method, lead sulfide and zinc sulfide can be separated. The next one, the ore after grinding is spread upon a roller in a thin layer and subjected to the influence of electrostatic field. Okay. Lead sulfide is a good conductor, kindly follow. It's a good conductor, is charged and is thrown away from the roller due to electrical repulsion. Due to electrical repulsion, it is thrown away, whereas zinc sulfide, a poor conductor, is not charged and dropped vertically from the roller. So we can collect separately zinc sulfide, we can collect separately the lead sulfide. This is the method we can apply with the help of electrostatic concentration. again. Kindly follow. The next another important method is chemical separation. By using chemical separation also, we can again concentrate a ore. Let me discuss here. This method is suitable for the separation of ores and the gangue which differs in reactivity. So it purely depends upon the reactivity. For each and every method, there is a basic principle involved. So in this case, the chemical separation based on the reactivity. Okay, specific example. Let me take now. For example, crude bauxite ore, molecular formula Al2O3.2H2O, can be concentrated by digesting with an aqueous solution of caustic soda. By aqueous solution of caustic soda, nothing but sodium hydroxide at temperature 425 to 445 Kelvin under pressure for several hours. So you take aluminum oxide Al2O3.2H2O and heat strongly with sodium hydroxide 6 moles at temperature 425 to 445 degree Kelvin for several hours. What will happen now? Aluminum oxide will be converted into sodium aluminate. So aluminum present in this bauxite dissolves forming soluble sodium aluminate. So sodium aluminate molecular formula Na3AlO3. So what will happen here? The water, extra water will be getting eliminated. When water is getting eliminated, it will be getting concentrated. The percentage of aluminum it is present in this will increase. This is the most important information here. Okay, the next step. After getting this sodium aluminate, and again what we have to do, we have to add in process of, that is the diluted with water in presence of calcium hydroxide. So what will happen now? We will be converted into aluminum hydroxide. Sodium aluminate will be converted into aluminum hydroxide and sodium hydroxide is also forming. So what will happen now? The sodium extra present will be eliminated in the form of sodium hydroxide, further concentrating to aluminum hydroxide. So our aim is we have to concentrate aluminum metal. So from sodium aluminate it is converted into aluminum hydroxide correspondingly. So now under aluminum hydroxide sodium is eliminated. So now what will happen now? This aluminum hydroxide when you heat, calcinate at higher temperature, converted into suitable form of Al2O3 and again water is getting eliminated. So we are getting final form Al2O3. So this is the suitable form. We are concentrating with the help of chemical separation. Kindly follow. This is the specific example I have pointed out. So by following any one of these methods, we can now concentrate. Okay, let me go for the third step. Conversion of concentrated ore into more suitable form. This is the another most important method. So I have discussed a number of methods to how to concentrate ore. So now what happens after concentration, after getting the suitable concentrated ore, and we have to convert it into a more suitable form from which we can extract profitably the metal or non-metal we are interested. So under this there are two methods available. One is calcination, another is roasting. These are the two important methods that is coming under this. I have to discuss under this step 3. Okay, let me go for first calcination. What is calcination? Calcination nothing but heating in the absence of air. Very simple. You heat any ore in the absence of air. So automatically decomposition. When you are decomposing, any water is present will decompose, any gas will be eliminated. So automatically the concentrate more suitable form will be converted normally, either from oxide form mainly will come. Okay. Calcination is a process in which the ore is heated strongly in reverberatory furnace. It's the special furnace. I am going to show the diagram also. Reverberatory furnace in the absence of air to remove unwanted impurities like water and volatile gases like carbon dioxide, sulfur dioxide. This is the most important. Let me repeat again. Calcination is the process in which the ore is heated strongly in a special apparatus called a reverberatory furnace in the absence of air to remove unwanted impurities like water in the form of steam and volatile gases like carbon dioxide, sulfur dioxide also. So specific example, suppose, let me take calcium carbonate. So the calcium carbonate ore now when I heat converted into calcium oxide and carbon dioxide will be allowed to escape. So I am getting a more suitable form is oxide form, calcium oxide, from which I can extract profitably. The same way, bauxite ore, aluminium oxide, Al2O3.2H2O, when I heat strongly in the absence of air, converted to aluminium oxide, again water is getting eliminated. So I am getting the most suitable form is Al2O3. This is a specific example I am giving under the calcination. Kindly follow. It is the process in which the ore is heated strongly in a special apparatus called reverberative furnace in the absence of air. Okay. So what we are here seeing is a reverberative furnace. I already pointed this is the reverberative furnace. Actually, what is happening? Kindly see here. This part, what I am showing this part, in this part, so it's a fireplace. So we have to keep some fuel. We have to keep some fuel there, and bottom it is closed by iron bars. So fuel, it is placed over the iron bar, closed by iron bar. Okay. By allowing this fuel to burn, we can produce heat. Okay. Now, just parallel to this fireplace, there is a place. This is called hearth. I already indicated. This is called bed or hearth, where whatever ore material to be heated, we can place. So kindly follow. This is the two important thing you must know. First thing, this is a fireplace where we are keeping a fuel over the iron bar, closed by iron bars. And parallel to this, there is a place called bed or hearth where we are keeping the material to be heated, or ore or whatever you purify that is converted to a form can be placed. Now what will happen now? So the furnace will be in the form of a concave surface. Kindly follow. This surface is concave, it is connected to a chimney. Concave surface. Right. So what will happen when the fuel is allowed to burn? So what will happen now? The heated gases or flame, because of the concave nature, will come and contact with the material to be heated. So automatically this will be heated at a higher temperature. The material or ore that will be placed in the bed or hearth will be heated at a higher temperature. Kindly follow. So using this reverberative furnace, we can do calcination as well as oxidation or reduction also we can do. This is a special apparatus. What way? Suppose I want to do reduction, I will use some reducing agent there, automatically I will be heat. Suppose I want to do oxidation, I will allow to pass through air, automatically the burn with the air means automatically oxidation will take place. So I can do calcination as well as I can do oxidation or reduction also. So depending upon the condition required, I can use the suitably reverberative furnace. This is the most important. Kindly follow the instrument called reverberative, commonly used in the extraction of metals. The next is roasting. Kindly follow. This is another process, roasting. Roasting is the process in which the ore is normally heated in a regular supply of air. Kindly follow. Regular supply of air in a reverberatory furnace or in a blast furnace. So either I can use reverberatory furnace, just now I have discussed, or I can use a blast furnace, I will show you later, at a temperature below the melting point of the metal. This is the most important condition. Kindly follow. Let me repeat again. That is, roasting is a process in which the ore is heated in a regular supply of air. Heated in a regular supply of air in a reverberatory furnace or in a blast furnace at a temperature below the melting point of the metal. This is the most important. Below. You should not heat above the melting point. Below the melting point of the metal. This is called roasting. So what will happen? During roasting, the volatile impurities are removed. Volatile impurities are water in the form of steam and gases like carbon dioxide, sulfur dioxide, all the gases will be going off. And the ore generally change into its oxide form. This is another interesting information. In roasting, we are converting any minerals, metals into corresponding oxide form. So from which we can extract profitably the metals. So this is the interesting information regarding roasting. The main difference is the calcination and roasting. Calcination is the absence of air, roasting is the presence of air. That is the mainly we can use either reverberatory furnace or blast furnace we can use. Any form. So what we are seeing here, it is the blast furnace. Reverberatory furnace, I have explained. What is this furnace? So here, automatically here it is indicated two things. That is, the heated air, the unwanted gases we can allow to burn, and this heated air can be allowed to pass through these two siders at the bottom. So at the entering state, it will be very, very high temperature, 2170 Kelvin, 2170 Kelvin, very high temperature. When the gases move upward, the temperature slow down. Here, 1570 Kelvin, here 1270 Kelvin, and the top almost 1700 Kelvin. So at the top lower temperature, the bottom high, very high temperature. So what will happen now? So we are adding from the top, with the help of a hopper, we are adding the ore along with the corresponding the carbon or any other slag, anything like that. So when we are adding the ore, it is passing through the different temperature in the blast furnace. So the different products are formed. So the different types of products are collected in 3 different places. What are they? So at the bottom, here on the left hand side, we are getting a slag, impurities we are getting. Molten, that is slag, which are lighter than the metal, we are getting from the left hand side. And here at the bottom, the heavier metal, mainly for iron, like metals, molten metal, we are collecting at the bottom. So the second place. And third, the eliminated gases will escape from this at the top, will go away. That is carbon dioxide or SO2, all these gases will escape. So there are 3 different products. One is impurities, we are collecting separately at the bottom, and the required material, that is iron like metals, we are collecting at the bottom, and the top we are eliminating the impurities like SO2, CO2, etc. Even H2O it will remove from the top. So this is the way we are using the blast furnace, this purpose. Okay. So under the roasting, let me explain now. What is happening? So zinc sulfate specific example, a sulfate ore, when they are heating with oxygen in the process of blast furnace, converted into zinc oxide, sulfur dioxide gas will be liberated, which will escape at the top. The same way, lead sulfide 2 moles, when you heat with again 3 moles of O2, converted into again lead oxide ore, again sulfur dioxide will escape. The same way, the Cu2S, cuprous sulfide, again in the excess of oxygen in the blast furnace will be converted into cuprous oxide, and again SO2 gas will be converted. So kindly follow, in all these sulfide ores, in all the cases, zinc sulfide, lead sulfide, cuprous sulfide, all the sulfide ores will be converted into oxide ore during roasting, because we are heating in presence of oxygen. So when this converted into corresponding oxide ore, the unwanted impurities, SO2, it is escaping at the top in the blast furnace I have already shown you. So this is the reaction that is taking place in the roasting. So let me conclude. So what I have discussed, what is the, let's see, when in the beginning of the class I have just discussed what is the difference between minerals and ores, what are the important ores that are available in India and other outside countries I have discussed, and I have discussed the classification of ore I have discussed, and also I have just indicated 5 steps I have indicated the method that normally follow to extract metals from the corresponding ores. And I hope you can enjoy the lecture. Thank you.